Welcome back, students. Today we are going to continue working with slope, but we are going to apply using slope and we will use it to graph equations of lines. So just as a reminder, slope is sometimes called your rate of change. We had a formula for it that we worked with last time. We also said that we use the letter M to represent your slope. In order to graph the equation of a line, all you need to know is one point that is on the line. Maybe you'll be given 2 points. That's okay. We can plot two of them and then connect them. But all you need to know is the starting point. You need 1 point on the line, and then you also need to know how does the line move. So that's the slope. That's why I like to think of M. How do we remember that? M is your slope. It's how you move. That's what slope does. Is how are you going to move? So you need a point to start with, and then you're going to know where to go. Okay, so this first example says graph the line with slope -2 that passes through the point -3, 4. Okay, so -3, 4 is on this line. So that's my starting point. So remember when you graph a line, 0, 0 is your origin, -3 is your x-coordinate, and your x-axis is this horizontal axis, and your y-axis is the vertical axis. So when it says -3, it means you go over to -3 on the x-axis. 4 means you go up to +4 on the y-axis, and then where those intersect, that is where your ordered pair is located. So we have an ordered pair at -3, +4. Here is where we plot a point. This is where we start. Our slope is -2. So I'm going to write that, -2. Sometimes it's helpful to write it as a fraction, -2 over 1. Okay, so this -2 is telling me that I'm going to go down 2, because remember, your top number tells you how much you go up or down. So if it's positive, you're going to go up. If it's negative, you're going to go down. And then the 1 on the bottom tells me that I'm going to go to the right by 1. Okay, so always go to the right. If it's negative, you go down. If it's positive, you go up. Okay, so where I'm going to move, where I'm going to make my next point is from here, I'm going to go down 2 and to the right 1. And where I land, I plot a point. And I can do this as many times until I run out of room on my graph. So I'm going to go down 2 to the right 1, 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 down 2 to the right 1. Now notice that this pattern, okay, if I now want to reverse it, the reverse of it would mean up 2 to the left 1, up 2 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 left 1, and I can plot a new point, up 2 left 1, up 2 left 1, and now I've plotted as many points as I can that are on this graph, and the final thing that I would need to do is connect the points with a line. All right, so do the best that you can, especially if you're like me right now and you're doing this without a ruler. Make your line, and a line could keep going on forever and ever. So if you can, go ahead and put arrows on it, showing this line could go on forever. What we just did there, using slope and using a starting point, okay, that is how we are going to graph lines. Now, sometimes we're going to be given a very specific starting point, and that starting point is going to be called the y-intercept. Okay, so the y-intercept is where the line will cross or intersect the y-axis. Okay, so the slope-intercept form is what we have right here. Slope-intercept form is the formula y equals mx plus b. So y is your dependent variable, x is your independent variable, m is your slope, and b is the starting point. But it's a very specific starting point. It is the y-intercept. Okay, so your y-intercept, that is always going to be an ordered pair with an x-coordinate of 0. And then the y value is just going to be wherever it touches, where is it on the y-axis? And again, we use the m, the letter m, to represent it. The slope, remember, is how you move. That's your rise over your run. Okay. So when you're given an equation that's in this form where it's solved for y, and you have y equals something times x plus b, always just look to see what's the number in front of x. That's your slope. That's your m. What's the number after x? What are you adding? What are you subtracting? That is the y-intercept. So let's look at an example of that. So here we have an equation that solves for y, so our dependent variable is by itself. Y equals negative 2/3 x plus 4. So if I write the formula on top of it, so y equals mx plus b. The number in front of x, m, the number in front of x, this is my slope of my line. So I'm going to write it as a fraction. This one already is. It's negative 2/3. I'm going to put the negative up with the numerator, but it can go on the outside or it can go down at the bottom. It means the same thing. There's one negative sign, there's one negative sign. This is negative 2/3, which means I'm going to go down 2, and the 3 on the bottom means I'm going to go to the right 3. Now this tells me how to move, but I need to know where am I going to start. I need to have a point to originate at, and this is where the b comes into play. So notice that this is plus b, so here I am adding 4, so my b is 4. Writing this as an ordered pair, it's going to be 0, 4. So this is my point that I need to plot first. So on my y-axis, because I don't go left or right any, it's 0, a number always for a y-intercept, I'm going to go up to positive 4, and I'm going to plot my initial point. You always have to have a point to start with before you can move. So now we have our point, and now we're going to move. And our slope is negative 2/3, so we're going to go down 2 and to the right 3. You're going to go down 2 more and to the right 1, 2, 3 and plot a point. Down 2 and to the right 1, 2, 3 and plot a point. If I continue, I'd go off the page. So now I'm going to reverse it. So instead of going down 2, I go up 2 to the left 3. So up 2, left 3, up 2, left 3. So now I'm going to go up 2, left 1, 2, 3, up 2, left 1, 2, 3, up 2, left 1, 2, 3. Plot a point. And then connect these points the best that you can, and that was terrible. But connect these points the best that you can with a straight line. So I'm going to cheat, and I'm actually going to come over here, and I am going to grab the line tool. Okay, there we go. And I'll put arrows to say that this line would continue forever. Overall, notice that this graph, when I read it from left to right, it's going down, which is a good indicator that I did it right because my slope was negative. My next example, I'm given an equation of a line, but it's not in the form y equals mx plus b. So what I need to do is I need to solve for y first. So this is where solving an equation comes into play. So I have negative 6x plus 2y equals negative 10. So first thing I'm going to do is I'm going to move 6x to the other side. There's my equal sign. I split left from right. So to move minus 6x, the opposite of a minus would be plus 6x. I'm going to put plus 6x. So I'm going to have 2y because negative 6x plus 6x cancels. I'm left with just positive 2y equals, and then over here, I'm going to bump the negative 10. Okay, it goes mx plus b. So I want to put the term with x first. So it's positive 6x, and then negative, so I'll put minus 10. Okay. To get y by itself, it's almost there. It's by itself, but now it's being multiplied by 2. Okay, so now I'm going to have to divide every one of these numbers that I see by 2, every term by 2. So 2 divided by 2 cancels, leaving me with y equals 6 divided by 2 is 3, and then I have my x, and then negative 10 divided by 2 is negative, so minus 5. Okay, now that's of the form y equals mx plus b. So I identify m is in front of x. What's the number in front of x? It's 3. I'm going to write that as a fraction, so 3/1. What this tells me is I'm going to move up 3 because it's positive, so I'm going to go up and then to the right by 1. You always move to the right, but if it's positive, you go up by however much that number is on top, and if it's negative, you go down by however much that number is on top. B is the number in the place for B, so it's a 5, but not only that is you have to include the sign in front of it. All right, so for our last example, it was already a positive 4, so I just wrote 4. But this one's a negative 5, so the y-intercept is negative 5. So that, as an ordered pair, is 0, comma, negative 5. So when I plot that point, here's 0, and I go down to negative 5. So negative 1, negative 2, negative 3, negative 4, negative 5. That's right here. And then from this point, I move with my m, my slope. So it's up 3, so 1, 2, 3 to the right 1. Up 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 1, 2, 3 to the right 1. Or down 1, 2, 3 to the left 1. And then I'd run out of room. Okay, and then we will connect all of our points. And if we can't connect them with a straight line, it means we've messed up on one of our points somewhere. But I believe I got a line through all of these, and then I'll put my arrows to say this line continues. Overall, looking at this line as a whole, notice that on the left side, the farthest left that I have, it's down low, and then it goes up high. So it goes from low to high. It's increasing from left to right, which is a good sign because my slope was positive 3. All right, next ones, these other special types of lines. Okay, so for these special types of lines, horizontal lines and vertical lines. So a horizontal line, okay, remember that a horizontal line always goes from left to right. Doesn't go up or down any, it goes straight left to right. Okay, this type of a line is only going to go through your y-axis. So that means that it's going to always be y is equal to a number. The y value stays constant. Versus a vertical line, this is one that goes straight up and down. This is going to go through the x-axis, so it's x equals a number because the x is going to stay constant. So if we have the graph of the line y equals negative 3, we're going to start on the y-axis at negative 3. So negative 1, 2, 3, we're going to plot a point. And then we only move to the left and we move only to the right. It only goes through the y-axis. So then we would draw a line that is a horizontal line. When we have x equals a vertical line, so x equals 4 on the x-axis, you find positive 4 and you plot a point. And then this only goes through the x-axis. If I tried to make the line go left and right, I'd go through the y-axis. This only goes through the x-axis, so I'm going to go up and I'll go down. That's it. And there would be my vertical line. Okay, so remember there are 4 types of slope, where you have a positive slope and a negative slope, a slope that is 0 or a slope that is undefined, which means that you are going to have 4 possible cases for what your graphs look like when you graph them. A graph that's going down, a graph that's going up, a graph that's just going left and right, which is a horizontal line, or a graph that only goes up and down, which is a vertical line. And how I graphed every single one of these was I started off by plotting a point, and then I used my slope to move. Okay. Horizontal and vertical were a little bit different. Okay, but in general, you just start off with one point, and then your m, your slope, tells you how to move. And that is how you graph lines.